Hi, today we are going to present about sound level meter. For the components of content, we have agenda. The second one is introduction to noise pollution. The third one is case study area, and the fourth one is objective. For the agenda, this study was carried out to measure the noise level at our selected location using a sound level meter. During this presentation, we will explain the test location, objective, result, and our recommendation based on the measured sound level. For the introduction, noise is any unwanted or excessive sound that can affect people's comfort, health, and daily activities. A sound level meter is a device used to measure the intensity of sound in decibels or dB. These tests help us to determine whether the noise level at a particular location is within acceptable limit and identify possible sources of the noise pollution. For the case study area, our sound level measurement was conducted at UiTM Campus Samarahan, Block M. This location was selected because it experienced regular human activities, any car, any vehicle movement, making it very suitable for measuring environmental noises. Measurements were taken at several points to obtain accurate and representative data. For the objective, we have 4 components, which is measure, identify, compare, and evaluate. For the measure is to measure any environmental noise level using a sound level meter. The second one is identify, to identify the main source of noise at the study area. The third one is compare, to compare the measured sound level with the recommendation noise limit. Lastly, evaluate, to evaluate whether the environmental provides a comfort and safe level of noise for the public.
The function of each instrument. First is a sound level meter. A sound level meter, or SLM, is used to measure the intensity, loudness of sound. It is used to measure noise level and measure how loud is the sound is in decibel. For example, a heavy traffic is measured around 80 to 90 dB. For tripod, it is used to hold the instrument steady at the correct measurement height. This is to prevent the meter from shaking or moving during measurement, giving more accurate reading. Lastly, a stopwatch is used to accurately measure time taken from activity or observation. During noise measurement, it is used to control the duration of sound level meter and ensuring accurate and consistent result. Next is dBA and LEQ use. dBA is used because it measures sound according to the sensitivity of the human ear, giving realistic indicator of perceived loudness, while LEQ is used because it provides the average noise level or over a period of time, making it suitable for assessing fluctuating noise and comparing it with acceptable noise limits. For the measurement condition, is the sound level meter was mounted on a tripod above the ground. It was set to a dBA and LEQ mode, and the stopwatch was used to measure required monitoring period. Measurements were taken in the dry, calm weather, away from reflective surface, while avoiding nearby movement and conversation to ensure accurate and reliable noise reading.
My name is Farina, and I will be walking through the measurement procedure and precaution steps that we took to go through with this sound meter test. Moving on to our measurement procedure, we chose the location to be in front of Block M, where it is a high traffic area for both students and lecturers who attend classes during the day. The test was done close to lunch hour, where there was peak activity, with high volume of passing cars or motorcycles or footsteps by everyone passing by. For the equipment setup, we downloaded a mobile app called SPL Meter, dB, and Sound Meter on a smartphone, and then we put it onto a tripod where it is to keep it completely stable for accurate data readings. For the data collection, we tabulated every minute of data taken by the sound meter application It was a total of 30 minutes where every minute we tabulate the data with sounds like footsteps or chatter or engine noises. Next, we can move on to the precaution steps. To ensure our readings were highly reliable and accurate, we took a few strict precautions. First one is consistent timing. We constantly monitor the clock to record data exactly every minute mark for 30 minutes. Next, we made sure of stability control. We ensured that the tripod remained stable and unaffected by wind or passing traffic vibrations. There is also self-noise reduction, where our team remained as quiet as possible and stood back to ensure that our own voices wouldn't interfere with the sound meter readings. Lastly, there is clear microphone obstruction, where we made sure that the phone's microphone was facing completely at the main source of the noise with nothing covered to ensure that the meter was reliable.
This is the result of noise measurement at Block M. Based on the measurement conducted at 12 p.m. until 12:30 p.m., a total of 31 sound level readings were recorded using the sound level meter application. I will explain the result table. The table shows the sound pressure level SPL recorded at 1 minute intervals together with the observed source of noise. The recorded noise level ranged from 59.4 dBA to 84.4 dBA. The highest noise level, which was 84.4 dBA, was recorded at 12:25 p.m. This high reading was likely influenced by nearby traffic and pedestrian activities. The second highest reading was 83.5 dBA at 12:21 p.m. when a car was observed passing by the measurement area. Meanwhile, the lowest noise level was 59.4 dBA at 12 p.m., which indicates a relatively quiet period with fewer noise-generating activities. From the result obtained, traffic noise were identified as the major contributor to the increase in sound level. For example, when car or motorcycle passed the measurement area, the sound level increased, reaching more than 80 dBA on several occasions. Meanwhile, during periods with less traffic and fewer people, the noise level decreased to around 60 dBA. This indicates that transportation activities and pedestrian movement have a direct impact on the environmental noise level at the study location. According to the World Health Organization (WHO), the recommended environmental noise level for outdoor living area is approximately 55 dBA during daytime. Our measurement recorded value ranging from 59.4 dBA to 84.4 dBA, which are generally higher than the WHO recommended limit. Therefore, the study area can be considered relatively noisy, especially during periods of heavy traffic and high human activity. Long-term exposure to excessive noise may affect concentration, communication comfort, and overall well-being. In conclusion, the noise measurement successfully identified the sound level and major noise source at the study area. The results show the vehicle's movement and student activities were the primary contributor to environmental noise. Most of the measured value exceeded the WHO recommended guidelines of 55 dBA, indicating that the area experienced a moderate to high level of noise pollution. The things that can be done to reduce noise level in the area, several measures can be considered, such as plant more trees and vegetation to act as natural sound barrier. Secondly, control vehicle speed and traffic flow near the area. Thirdly, raise awareness among students and visitors to minimize unnecessary noise. And lastly, conduct regular noise monitoring to assess future conditions.